Welcome everyone, I'm Adam. In this problem, we're going to take our given point in rectangular coordinates as 0, 5, and 1 and convert that from rectangular coordinates to cylindrical coordinates. So, starting with taking a look at what we want, we have our point 0, 5, 1 in our coordinates x, y, and z. And it's going to be helpful to help us find our point in cylindrical coordinates to graph this. So to start with, I'm going to graph this point 0, 5, 1, and then we'll come back to it. So we have x value 0 at the origin, y is 5, and then z is 1. So we have our point in rectangular coordinates 0, 5, and 1 right there. And like I said, we'll come back to that in just a little bit. Now what we want again is we want to go from rectangular coordinates, which are in terms of x, y, and z, we want to convert that to cylindrical coordinates. So in terms of r, theta, and z. Okay? So to do that, we're going to use some of our conversion equations. So what do we know? Well, we know that, say, r squared is equal to x squared plus y squared. So right away we can find a value of r, namely taking r squared is equal to what is x? X is 0, so 0 squared plus y, or 5 squared. So r squared is equal to 5 squared, and then solving for r, taking the square root of both sides, technically the plus minus, so r is equal to plus or minus 5. So that tells us there could be two possible values of r. And we're only going to choose one of them, but we'll come back to that in just a second. Right? And we'll determine which value of r we'll use when we determine which value of theta from the next part. So the next thing we want to do, if we have r, or at least some candidates, we want to find theta. So from theta, we start, again, with what we know, that tangent of theta is equal to, say, y over x. And that implies, well, theta is tangent inverse of, say, y over x. And again, we know the values of y and x. So this is equal to tangent inverse of y, which is 5, divided by 0. So as it sits, we can't evaluate this because we can't divide anything by 0. But we know from earlier sections in calculus that really evaluating this is kind of the same thing as looking as the limit, as say x approaches 0 on the bottom. And we'll take this from the two sides. X approaches 0, say from the left, of tangent inverse of, say, 5, which we know is y, over x. Okay? So x approaching 0 from the left means x is negative, and it's approaching 0 in the denominator. So that essentially means approaching 0 in the denominator with a constant on top. This essentially is approaching tangent inverse of, say, negative infinity. Right? And that we know from the graph of tangent inverse is equal to negative pi over 2. And likewise, we'll look at the limit as x approaches 0 from the right of tangent inverse of 5 over x. So x approaching 0 from the right, x is positive, but still going to 0. So that means that this is approaching, say, tangent inverse, or the inside is approaching positive infinity. So from the graph of tangent inverse, as x goes to positive infinity, we know this is positive pi over 2. So again, it looks like we have two candidates for what theta could possibly be. Now the convention is to take theta moving counterclockwise, or as a positive angle. So we're going to take theta as this pi over 2. Okay? Now the last thing that we have to look at is z. And of course, the z stays the same. Z is just equal to z. So z is going to be the same thing as it was in our original point, which is equal to 1. Okay, so we have z, we have theta. Let's maybe clarify that down here. So theta is equal to pi over 2. Now coming back to r, we had two possible values of that. Which one are we going to take? Positive or negative 5? Well, Now let's come back to our graph, and this is why I said this would come in handy. So again, what we have is theta is pi over 2. So from the x-axis, positive pi over 2 is going to be moving in this direction counterclockwise. So coming out from the origin to get to our point, or y value 5 over here, we're going to move out this way, positive 5, move our angle here, pi over 2, and then our z value up 1. So that's going to get us to our proper point. So r would be positive 5, and theta is pi over 2. So in the end, our point in cylindrical coordinates, r, theta, and z, is equal to r is 5, theta, pi over 2, and z is 1. Thank you very much.